Good day, everyone. It's nice to have you here once again. My name is Chidozie Kalu, and in today's class, we're looking at a new topic indices and logarithm. We would like to really encourage you to be part of the class, participate as much as you can, and please, during the course of the class, if you have any question, please kindly drop your questions in the comment section. It will be attended to. Thank you. See you in class.
All right, good morning. Welcome to class. Um, so today we'll be looking at indices and logarithm. But of course, we'll have to start with indices. In indices as a topic, we will be dealing a lot with powers, powers, powers. And when we say powers, what do we mean? I'm sure you've come across expressions like this: y times y. Of course, we know that this is equivalent to y squared. We've also seen something like m times m. Of course, we know that this is equivalent to m cubed. So looking at y squared and m cubed, those kind of expressions are what we call powers. So in indices, we'll be dealing with a lot of powers. So when we have an expression like y squared, the y is the base, the y is the base, while the 2 is the index. The y is the base, while the 2 is the index. Of course, if I have something like m raised to power 3, the m is the base and the 3 is the index. I'm sure you're very familiar with that now. The expression, the m cubed is power, y squared is power, y is the base, 2 is the index, m is the base, 3 is the index. So the plural of index is what we know as indices. So you're not dealing with something strange. It is something we are very, very familiar with. So just keep it in mind that for indices, we'll be dealing with mostly powers. And so we will start from the laws of indices. The laws of indices. There are laws that guide the operations of indices, and they are not difficult to understand. So we'll be exploring them in this class. So the first law is the law that involves multiplication of powers. We call it the multiplication law. The multiplication law. The multiplication law. Okay. Now, what does this law state? This law simply states that if I have two powers with the same base, that means if I have an expression like y a times y raised to power b, y raised to power a times y raised to power b. Now you observe, of course, that these two expressions have the same base. The base is y. Remember the introduction. The index for the first expression is a, and the index for the second expression is b. Now, this law states that as long as they have the same base, that what you obtain is y raised to power a plus b. So when two powers multiply and they have the same base, what we simply do is that we add up the index. So if I have something like 5 raised to power 2 times 5 raised to power 7, I know a layman would try to do something like this: 5 times 5 for 5 raised to power 2 times 5 times 5 times 5 times 5 till up to 7. I'm sure you're already getting bored at that. That's why this law is there for you to navigate. Now, you don't need to do all of this. What you simply do is to pick the base that they are sharing and then add the index. And so what you have is 5 raised to power 9. So this is what we know as the multiplication law. The next law is not as difficult. The next law is the division law. Division, the division law. All right. Now, it's more like the opposite of this. So this law involves the division of powers. So if I have something like um, 5 raised to power 4 divided by 5 raised to the power of 3. What am I supposed to have? According to this law, we have that as long as they have the same base, picking the common base will subtract the powers. So we're going to have 4 minus 1, which of course would give us 5 raised to power, sorry, 4 minus 3, run that error, 4 minus 3, which of course would give us 5 raised to power 1. I'm sure that was simple enough. Why not try this? So if you have 10 raised to power 5 divided by 10 raised to power 2, trying it on your own, you discover that you would have 10 raised to power 5 minus 2, which will give us 10 raised to the power of 3. Okay, I'm sure we are very okay with that now. Let's go over to the third law. The third law, would give us is what we call the zero law. Zero power law. Okay, what happens here? The general rule for this is any number raised to the power of 0 is 1. So if I have y raised to the power of 0, means that the answer is 1. How can we prove this? Assume that you have 5 raised to the power of 3 divided by 5 raised to the power of 3. Let's try and prove and know whether this law is correct. Now we know that by expression this is same as 5 times 5 times 5 divided by 5 times 5 times 5. If 5 goes in 5, we have 1. If 5 goes in 5, we have 1. 5 goes in 5, we have 1. Alright. Now what it means is that I have 1 times 1 times 1, which is 1, over 1 times 1 times 1, which is 1. This gives me 5. So you see, remember that 5 raised to power 3 minus divided by 5 raised to power 3 is, by the division law, you have 5 raised to the power of 0. So what it simply means is that this is equal to 1. Alright, if you are okay with that proof, we will go over to the next law. Now you need to be conversant with all these laws because you would have to solve problems with it. We'll go through all the laws first before we start looking at problems to solve where we apply some of these laws. Okay, the fourth law, sorry, the fourth law is the index product law. Now, what does it mean? If I have an expression like this, I have y, which is raised to the power of a, being raised to the power of b again. You could have an expression like this. What is obtainable will be, this law states that you have y raised to the power of, so these two indices will multiply themselves. You have a times b to give you y raised to the power of ab. Okay, so what it means is that if you have something like 6 raised to the power of 4 raised to the power of 3, this is equivalent to, this is equal to 6 raised to the power of 4 times 3, which of course is 6 raised to the power of 12. Okay, take a good look at it again. So what you do in this law is to multiply the powers. All right. The next law, the next law is the negative power law. The negative power law. Okay. Sometimes you see an expression like this, y raised to the power of minus a. Now, this expression is the same as 1 over y raised to the power of a. If you look at that expression, you will observe that the negative sign left. The negative sign left. So if you have something like 10 raised to the power of minus 6, it is the same as 10, sorry, according to our law, this is the same as 1 over 10 raised to the power of 6. Okay, all right. If that is clear enough, we will now look at the next law, and this is probably going to be the last. The next law is the fractional power law. Fractional power law. Sometimes the powers may be in form of a fraction. What do I mean by that? So you could have something like m raised to the power of x over y. M raised to the power of x over y. How do you handle something like this? Now this is equal to ym root y raised to the power of x. Take a good look at it again. Okay, what it means is that if you could have something like 8 raised to the power of 2 over 3. 8 raised to the power of 2 over 3 would give you 8 inside box cube root of 8. Of course, you know where the 3 is coming from. All raised to the power of 2. Of course, you know that from this expression, cube root of 8 is 2. Then remember that you have a power of 2. Of course, this would give you 4. All right, so that was a brief summary of the laws of indices. the laws of indices, the laws of indices, the laws of indices. All right, let's look at some questions that we could where we could apply these laws. All right, you could be given something like this to solve. Let's start with the simpler one. X raised to the power of 3 times x raised to the power of 5 all over x raised to the power of 2. Okay, now you are dealing with multiplication here and you're dealing with division, and you can observe that in this question all the bases are the same. The base is x. So what it means is that this is equal to x raised to the power of 3 plus 5. Now minus, because of the division sign, minus 2. This of course will give us x raised to the power of 8 minus 2, which is x raised to the power of 6. And just doing that alone would give you your answer. All right, let's look at some more complex questions. Okay, you could also be given something like this to solve. Whenever you're given a question in indices, part of the things you must ask yourself is what laws are applicable here? What kind of laws do I apply for this question? What kind of laws do I apply for this question? Okay, this is a word question. Let's look at this. 27 raised to the power of 1 over 3 raised to the power of 2. Okay, 27 raised to the power of 1 over 3 raised to the power of 2. Now, you must also understand that there are several things you can do here. You can decide to solve for what is in the bracket first. If you're solving for what is in the bracket, you know that you're going to apply the fractional power law straight ahead. But you could also decide to open up that bracket. If you're opening up that bracket, you know that you're dealing with index product law. I will show you the two things you could do. First thing, okay, you could have square root of solving now. So square root of 27, sorry, cube root of 27 raised to the power of 1. Now remember that you have another raised to the power of 2. So we know that our cube root of 27 is 3 raised to the power of 1 raised to the power of 2. So of course will give us 3 raised to the power of 2 because 1 will multiply 2. And then of course your answer would be 9. But then you could have a second, or let's call it our plan B. Our plan B. Now my plan B could be to say that I've been given 27 raised to the power of 1 over 3 raised to the power of 2. I could decide to open that up and I'll have 27 raised to the power of 1 over 3 times 2. This of course would give me 27 raised to the power of 2 over 3. Okay, now I can now apply my fractional power law where I have my box, put my 27, and I have 3 here, and then I have 2 here. Of course, you know that cube root of 27 is 3 raised to the power of 2. You still have your 9. Which one was simpler? Your choice to make. So that was just to show you that you could employ any method as long as it is the correct method to get your answer. Okay, let's look at some more problems where we have to deal with some other laws. Okay, I'm sure you've taken note of that. All right, take a look at this question. 36 raised to the power of 1 over 2 times 4 raised to the power of minus 1 over 2 times 5 raised to the power of 0. Okay, by now you should be able to solve something like this, but let's do it together. For beginners, I will counsel you to solve it differently. So I could bring my 36 raised to the power 1 over 2, solve it separately here, meaning that I would have to use my fractional power law. I have 36. I don't necessarily need to put 2 here because the square root already covers for the 2. Okay, but I have to put my raised to power 1, even though I know it's not really necessary because whatever raised to power 1 is 1. So for this, I have square root of 36 is 6. So I'm done with that. Then I come to the second term, which is 64. 64 raised to power minus 1 over 2. I will still apply the same method. What is the method I can apply? I could decide to say that I have my 64 in the box and I have my 2. Of course, I have already told you that 2 is not necessary. You can put 3 there. If it's any other number apart from 2, you can go there. Then remember that this is minus 1. Okay. Now if this is the case, you know that what you're going to have is square root of 64 is 8 raised to power minus 1. Remember our power product law. Remember our negative power law, where we'll have that this will now be 1 over 8 raised to power 1. The negative sign goes, which will give us 8. Okay, I'm sure that was clear enough. Now I'm done with the second term of that question. Now I come over to the third term, which is 5 raised to the power of 0. Now for this, remember our 0 power law, where we have that anything raised to the power of 0 is 1. So 5 raised to the power of 0 is 1. Now I now have to combine all of these. 36 raised to power half is 6 times 64. Okay, sorry. Okay, so remember, this is my answer for the first term. This is my answer for the second term. This is my answer for the third term. So solving together now, I have 6 times 8 times, wow. Sorry, there was a mistake. This is 1 over 8. Sorry, this is 1 over 8. So what I'm going to have here is 1 over 8 times 1. Everything, of course, would give me 6 over 8. Simplifying to the lowest term would, of course, give me 2 here, 3, 2 goes here, 4. So my final answer is 3. over 4. So this is your final answer. All right. I'll be leaving you with some assignments at the end of this class. But let's look at equations in indices. Let's look at equations with powers. Let's look at equations with powers. Equations with powers. Okay. Equations with powers. All right. So there are some equations given, and you're asked to solve it. And these equations have powers. And you could be given that equation, and you're asked to find the unknown. All right. Solve this equation. Okay. First one we are going to look at is 3x is equal to 27. How do I solve something like this? 3x. Now you must understand that in some equation, the unknown is the index itself. So if two powers of the same base are the same, then the indices are the same. What do I mean by this? If you have 2 raised to power a equals 2 raised to power b, then what it means is that a is equal to b. So this is going to be your guiding principle to solve something like this. Let me repeat myself again. If two powers of the same base are the same, then their indices, the indices are the same. So you see, this is the base, this is the base, so their powers are the same, and this is an equal sign. So what it means is that a is equal to b. So if this is our guiding principle, how do we solve this question? So first things first, is there anything I could do? This is the question you must ask yourself. Is there anything I could do to 27 to make it the same base as 3, as what the expression on the left hand side? So yes, there's something we can do. We could have 3x raised to power x, and we know that 27 is same as 3 raised to the power of 3. Now, if you observe, you discover that they are having the same base now. So if they are having the same base, what it means is that x is equal to 3, and that solves your problem. Okay, 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 let's have another problem. Let's have another problem. I'm sure by now you'll be able to do something like this. So you could have 2 raised to the power of 3x equals 4 raised to the power of 2x minus 5. Now, you will employ the same working principle. What does this mean? I ask myself, what can I do to 4 to put it in the same base with 2? So we are going to have 2 raised to the power of 3x equals, now remember that 4 is same as 2 raised to the power of 2. Now this is representing 4, but also remember that there was an existing power which is 2x minus 5. Alright, so if this is the case, I will have 2 raised to the power of 3x equals 2 raised to the power of, so I'll have to open up the bracket for the powers, and I'll have 4x minus 10. Now observe again that the bases are now the same. If the bases are the same, then it means that 3x is equal to 4x minus 10. So taking the powers now, I'll collect my like terms. Collecting like terms would give me that 3x minus 4x is equal to minus 10. Of course, this would give me minus x is equal to minus 10. The minus sign cancels out. I'll have that my x is equal to 10. That was pretty simple, wasn't it? All right. So with this, I will leave you with an assignment, and you drop your assignment at the comment section, and we will call it a day. All right. Take the assignment. Solve these equations. Solve these equations. First equation you're going to solve is 2 raised to the power 3x plus 2 is equal to 2 raised to the power of 2 raised to the power 4x minus 5. Okay, the second assignment, 25 raised to the power of 2 plus 3x is equal to 125 raised to the power of 4 minus x. Okay, and finally, also try this. 9 raised to the power of 2x minus 3 all over 3 raised to the power of x plus 3 is equal to 1. Okay, thank you for your time. It was nice having you around. See you in the next class.